So this module is going to feel like we're scattered a lot, but I'm going to bring it all back together when we meet in class on Monday so that you can kind of see how it all works together to influence the decisions that we make when we are trying to find zeros of polynomial functions. So the first two examples, we're supposed to use the remainder theorem. So basically, if something divides into something else evenly, so let's do 24 divided by 6. Okay, 24 divided by 6, 6 goes into 24 evenly or completely with no remainder, which means 6 is a factor of 24. Okay, so what if we do 13 divided by 2? Okay, 13 divided by 2. 13 divided by 2, 2 does not go into 13 completely, and you know, it has a remainder, which means 2 is not a factor of 13. So all we're going to determine is there a remainder or not. If there's a remainder, then we've actually found some more information. If there's not a remainder, then we found an intercept. So this one, I've got an x to the fourth plus 2, and I'm dividing by x minus 4. I don't have instructions, but I do know that I can use synthetic division because this is a linear factor with a coefficient of 1. So I'm actually going to divide by 4, and then notice I'm missing an x to the third, x squared, and an x. So I'm going to have a lot of zeros going across. But I've got 1 x to the fourth, no x to the thirds, no x squareds, no x's, and then my final answer is 2. Or my final term is 2. So I'm going to do the same process I've been doing. I'm going to drop this 1, and then multiply, put it in the next column, etc., etc. So 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 and 16 is 16. 4 times 16 is 64. 0 and 64 is 64. 4 times 64 is 256. Okay, 2 and 256 is 258. So here's what you just discovered. You have a remainder of 258. This did not go into your original polynomial evenly. There is a remainder. So x minus 4 is not a factor of x to the fourth plus 2, and 4 is not an intercept. It's not going to hit the x-axis at 4. But what we do know is that the point 4, 258 is on the graph. You just found a point. Okay, so 4, 258 is on your graph. So the question is x minus 4 a factor of x to the fourth plus 2? No, it is not, because there was a remainder of 258. So let's try it again. We have 4x to the fifth plus 19x to the fourth minus 5x to the third plus 6x plus 30, and I'm dividing by x plus 5. So boy howdy, do I want to use synthetic division because this is long. Okay, so what do I notice? First of all, I notice I'm missing an x squared, so I'm going to have a placeholder. Second of all, I can use synthetic division. This is a linear factor. This is an x to the first with a lead coefficient of 1. So in my little synthetic division box, I'm going to put a negative 5, and then I'm just going to list the coefficients. So here's my x to the fifth. Here is my x to the fourth. Here is my x to the third. I'm missing an x squared. Here's my x to the first, and there's my constant. So coming across, this is going to get gnarly. So drop your 4. Negative 5 times 4 is negative 20. So that gives me a negative 1. Negative 5 times negative 1 is 5. That gives me a 0. That is okay. Keep going. Okay, negative 5 times 0 is 0. Still gives me 0. What I want to do is keep going all the way to the end. So what do I have? Negative 5 times 0 is 0. That gives me 6. And now negative 5 times 6 is negative 30, which gives me a 0. So what did you just learn? X plus 5 is a factor of this polynomial. And this polynomial, when you graph it, will actually hit the x-axis at negative 5. Okay, so you found some information. All right, so for the next ones, we have show that the binomial is a factor of the polynomial. So I am told that f of x is 2x to the third, 2x to the third, minus 3x squared minus 3x plus 2. And I'm trying to find out, is x minus 2 a factor? If it is, can I keep breaking it down? So let's go back to my example of 24 over 6. 6 was a factor of 24 because it divided into 24 evenly, giving me an answer of 4. But I can keep breaking 4 down. 4 down would be 2 times 2. Okay, 4 broken down would be 2 times 2. So what I'm trying to do is break down this thing as far as I possibly can. So the question says, use the remainder, no it doesn't. It says use the factor theorem to show that the binomial is a factor of the polynomial, which means we better get an answer of 0 at the very end of synthetic division. And then once I do that, let's fill in and see what we've got. Okay, so the 24 over 6 was just my little example. Erase him so he doesn't confuse us later. So instead of using x minus 2, can I divide by x minus 2 using synthetic division? Yes, I can. This is an x to the first with a coefficient of 1. So I'm going to put a positive 2 in the little box. I've got an x3, x2, x1, no x. That looks like a j and it's really irritating me. Okay, there we go. No x, so I don't need any placeholders. I can just walk this whole thing down. So -3, and 2. So I'm going to drop this 2, not this one. I'm dropping this value right here to underneath. Multiply, put your answer in the next column, and go. So 2 times 2 is 4, which gives me 1. 2 times 1 is 2. That gives me -1. 2 times -1 is -2, and that gives me a 0. Okay? So what did you just find out? X minus 2 is a factor of this polynomial. I also found out that this polynomial crosses the x-axis at 2. That is what I just discovered. So the instructions say, use the binomial to find all the real zeros. Okay, so I do know that this is an answer. Here's our secret. Your biggest exponent on a polynomial equation will tell you how many answers we're looking for. I'm looking for 3 answers. I've got 1 of them. So there's 2 more out there. So let's fill this thing in and see what we've got. Well, if this was an x to the third, this is an x squared. So I have a 2x squared plus an x minus 1, and I want that to be 0. So here's the good news. I know how to handle this. I can either factor, I can complete the square, use square root method, or use quadratic formula. I don't care what method you use as long as it's mathematically sound. So I am going to factor this thing, which means I'm going to use factoring by grouping, or the AC method. So I've got first times last is a -2 x squared. Okay, I need 2 numbers that multiply to a -2, that when I subtract them I get 1. So that's going to be a +2 and a -1. But they need x's on them. Okay, because 2x times -1x is -2x squared. 2x minus 1x is x. So I'm going to trash this and put these 2 in its place. So I have a 2x squared, +2x, minus 1x. And so that took this place. And then I've got this -1 equals 0. Do not simplify or you'll end up right back here. But if I cover this up, what is 2x minus x? It's x. So I didn't change what this is, I changed what it looks like. Okay, so now I'm going to use grouping. What's common on your first 2 terms? I can pull out a 2x. What does that leave you with? That leaves you with an x plus 1. What is common on your last 2 terms? Remember, math people don't want to lead off negative, so whatever I pull out, it's going to be negative. Well, there's nothing else in common, so I'm going to divide out a -1. And that changes my signs to an x plus 1. So now tell me what's in common. I've got this chunk minus this chunk. What do they have in common? X plus 1s. So factor out that x plus 1, and that leaves you with 2x minus 1. Okay? So now I've got 2 factors. Don't forget about him. You already have a solution of 2. So let's actually put this up here. We have a solution of 2, which we call zeros. Why? Because they produce a 0. Okay? So I'm going to do the linear or the 0 product property. and I'm going to set each factor equal to 0. So subtract 1, I get another solution at negative 1. And I'm going to add 1, divide by 2, so I get another answer, or a 0, at 1/2. So I've got 3 solutions. I knew I was going to find 3 solutions, okay? And what I did was I divided this one out, and then I just factored what was left. So let us try it again. We have, I'm looking to see what else we have to do. All right, g of x equals 3x to the third minus 8x squared minus 5x plus 6. And I am dividing that by x plus 1. So the question is, use the factor theorem to show that the binomial is a factor, which means I better get an answer at the end, otherwise I screwed up, because I've already been told that this works. Okay, can I use synthetic division? This is an exponent of 1 with a coefficient of 1, so yes, I can use synthetic division. So in the little house, we're going to put a negative 1. Am I missing anything? x3, x2, x1, no x. Everything's complete. I don't need any placeholders. So I got a 3, a negative 8, a negative 5, and a 6. And again, I better get a 0 here. Okay, drop your 3 down. So negative 1 times 3 is negative 3. That gives me negative 11. Negative 1 times negative 11 is 11. That gives me 6. Negative 1 times 6 is negative 6. And oh my goodness gracious, we have a 0. So we just figured out that x plus 1 is a factor of this polynomial, and that negative 1 is a 0 because it produces a 0. So I'm going to come down here. Instead of calling them solutions this time, I'm going to call them zeros. So one of the answers of the 3 I'm looking for is negative 1. That's one of the zeros. So what do I have now? I started with a 3x to the third, which this is now a 3x squared, which means I can factor this or use quadratic formula or something. Okay, so how do I do this? I do this rapidly in my head. I multiply the first and last, which is 18. Do I know 2 factors of 18 with the same sign that will add up to negative 11? Yes, I do. Negative 9 and negative 2. So I'm going to go ahead and say this thing is factorable. Otherwise, I would go to quadratic formula. So I have an 18x squared. My 2 values have got to be negative because I got to multiply to a positive, and I'm looking to sum to a negative. So I've got a negative 9x and a negative 2x. So I'm going to trash this middle term and put those 2 in its place. So 3x squared minus 9x minus 2x plus 6 sorry, is 0. Everything is fine. All right. So don't combine these or you'll end up with this. So I'm going to do factoring by grouping. Look at your first 2 terms. What can I pull out? I can divide out a 3x, which is going to leave me with an x minus 3. Look at your last 2 terms. I know I'm going to pull out a negative, and I can pull out a 2. So I'm going to pull out a negative 2, so that'll change this to a positive term and a negative term. So I got what's in parentheses, and I've got what's not in parentheses. So I'm going to have 2 factors. When I multiply them together, I get 0. One of them must be 0. So either this one can be 0 or this one can be 0. So to solve, I'm going to add 3. I'm going to add 2. So x would be 2/3, x would be 3, or x would be negative 1. So what are we looking for? I'm looking for 3 solutions. How many did we find? We found 1 by division, and then we factored what was left. So my other 2 zeros are 3 and 2/3.